Hello. So today we will be discussing how the telecom network works as the title of the presentation suggested. So I'll be trying to give a very high level view of the whole telecom network. Then I will be discussing each of the components, how does it interact with each other and how does it work. We'll not be going into the details, rather we will try to understand the whole network from a very top level, so that it will give you a bigger picture view when we go to the details of the service. This presentation is not targeted to the completely technical persons. Rather, it would be targeted for the general users who want to work in the telecom network. This presentation will give you a very brief and overall idea about how telecom network works. Let's see what components are available in a telecommunication network from a very high level view. Those who use the mobile phone or telecommunication equipments can think that this mobile device is the main component of the telecommunication network. Since mobile is the most common device or most available device in the market, we can consider it as the main telecommunication equipment. So user can connect to the telecommunication network by this device through the access network. So what is access network? This access network can be a situational thing. The way I want to define this is it changes over time. So it cannot be a single medium of technology that can be defined as access network. So I'm trying to summarize access network as maybe BTS, BSC and backhaul communication link through microwave link, or can be anything else. As a whole, it is called access network. Primarily, users are connected with the mobile switching center or mobile core network by this access network. Every user connects with the core switch through the access network. Here we can see the several servers or machines, and this is called core network of a telecommunication network. One operator network is connected with another operator network. Like for example, Banglalink is connected to Grameenphone, or Grameenphone is connected to Airtel, or something like that. And for this connection, there is a component which is called interconnection switch. And this interconnect switch connects one mobile operator to another mobile operator, as I said earlier. In different situations, interconnect switch connected with different components. Like to connect with another operator, sometimes it uses direct connectivity and sometimes it uses interconnect exchange. To connect with the international call, it uses the international gateway. Moreover, for the roaming subscriber, particularly for the international roaming subscriber, use the roaming link to connect with the operators of the foreign countries. However, telecommunication is no longer a voice call or SMS. Rather, a big portion of the telecommunication network is used for the internet usage, and this is the most demanding thing. So to connect with the internet, internet gateway is used. Internet gateway is combination of different components. Like for the CDMA network, it is combination of PDSN, router and final internet router. For GSM network, it is a combination of SGSM and GGSM. As a whole, there is an internet gateway which connects the subscriber with the internet. Other components are operator's own element. To recap, users are connected to the serving switch through the access network. To register every user, there is a registration server which we call the HLR, or home location server. Primarily, it authenticates the user and then gives authorization to use the service. HLR contains the information of user location. That means the location user's registration. When a user wants to avail the service, then he takes authentication and authorization from the HLR. If HLR permits and do the authentication and authorization, then only the user can avail the service. If HLR denies, that means the user cannot use the service. User can take several services, but the voice call is the main one that the user takes. MSC itself processes the voice call. It only takes authorization from the HLR. Other type of commonly used service is SMS. User request comes to the HLR authentication first through the access network, and then it forwarded to the SMSC. So if only HLR permits or gives the authorization, only then it is forwarded to the SMSC. After receiving the request, SMSC processes the request. We have another similar kind of service which is called USSD service. And USSD gateway is responsible for this type of service. USSD service is like if we want to check the account balance, then we dial *1234#. Then we get the information of the account balance. This kind of service is delivered through the USSD channel. If you dial a number, no call established. Rather than in return, we get a message. So this kind of service is delivered through the USSD channel. There is another kind of service like the internet gateway to avail the internet service, which is called WAP service through the WAP gateway. Initially, when internet service was not available to the mobile, then WAP was the only service by which we can access the mobile specific sites. Though we can avail the service like Facebook, Yahoo and Google by the internet gateway and bypass the WAP gateway. But if we want to use any service which uses WAP protocol, then only we have to use the WAP gateway. If we want to know the precise location of a subscriber, that means not only the BTS location but a little bit more specific, like within the radius of 1 meter or 5 meter or 10 meter, then we have to use the location server. For the CDMA network, it's called the position detector, and in GSM network, it is called GMLC. This service tells the subscriber's location. If we want to know the location of a subscriber, then this service will tell the tentative latitude and longitude of that subscriber. As a whole, these are the services that we deliver to the subscriber. But telecommunication is a business. Here, subscriber is charged for every service. There are two types of charging. One is prepaid charging, another is postpaid charging. So for prepaid charging, IN or Intelligent Network System is completely responsible. Another is postpaid billing. This means subscriber will use the service and then CDR will be generated. We'll bill the subscriber with the help of this CDR. There is a billing software and bill will be generated with the help of the CDR. CDR is collected from different serving element like SMSC, switch, internet gateway and WAP gateway also generates CDR, and it is processed for billing. Prepaid billing means we have to pay first before we use the service. Now we can see what are the purpose of AAA is. AAA has multi-purpose. AAA stands for authentication, authorization and accounting. AAA has some functions of HLR and some functions of charging. In general, network billing, there is either IN billing or postpaid billing, but AAA charging is done with the combination of IN and postpaid billing. In postpaid, CDR is generated for billing, and for prepaid it triggers IN for billing. AAA receives requests from either from WAP gateway or internet gateway. For internet authentication and authorization is done by HLR and AAA. Location server is independent. User cannot use it directly, rather information is fetched by other applications. We can serve several services to a user by the telecommunication network. Once upon a time, we can't think beyond the voice call or SMS. But nowadays, situation has changed. Now we can serve wide range of services in the real telecommunication network. So we can call it service delivery channel rather than the telecommunication network service. It is not really one service delivery channel, rather it's multiple service delivery channel. There are 3 service delivery channels in one telecommunication network. One of them is call. Call contains 3G network and LTE network. There are 2 types of call. One is voice call, another is video call. Then other most popular channel is SMS. There is another similar kind of channel which is called USSD. Earlier we have already shortly discussed. So here in USSD we can send short messaging or text messaging with the user. The main difference between SMS and USSD is secured channel and session based communication with user. When user asks for a request, then an independent session is started and user receives the message by this session. It is a bit more real time and more secured. and user can receive different information by interacting with this. However, SMS is kind of store and forward. When a user wants to send message, then this message goes to the SMSC and stored there. Then it is delivered to the other party according to the destination. Then today's most popular channel is data. Here user can avail the WAP and internet service. At first, we have to know how a call is processed in telecommunication network. Primarily, we can see three types of call. One is on-net, other is off-net, and another one is peer-to-application. Peer-to-application call means when a subscriber gives a call, then this call is received by the IVR or picked up by any application. Now we will see what on-net call is. When calling party and the call party both are from same mobile operator or both lies in the same telecom operator network, then it's called the on-net call. When either of the calling party or the called party are from the different network, then it's called the off-net network. Like subscriber is in our home network and the other party is in a remote network. For example, call is going from Grameenphone to Robi. If we think from the perspective of Robi, call is coming from Grameenphone, so it's an off-net call. Again, from the Grameenphone's perspective, it's an off-net call. For Grameenphone, it's an outgoing off-net call, and for the Robi, it's an incoming off-net call. So we see that there's two types of off-net call. One is incoming off-net call and another is outgoing off-net call. Now we try to understand how this call establishes. At first, call comes to the serving MSC. Serving MSC is that component with whom subscriber is connected through the access network. When a call comes to the MSC, then verifies the call by the HLR and find out that whether the subscriber has the authorization or not. If the HLR authenticates, then only the call is forwarded to the second party. If the called party receives the call, then they can talk to each other. Whenever the call is finished, then CDR is generated by the switch. If it is an off-net call, then MSC sends it to the interconnect switch. An interconnect switch then sends it to the other operator. If it is an off-net incoming call, calls come to the interconnect switch from the other operator, and interconnect switch sends it to the MSC. Then MSC verifies the call with the help of HLR and call is delivered to the subscriber. If it is a peer-to-application call, then it comes to the MSC and MSC sends it to the HLR for the verification. Again, routing is configured in such a way that call comes to the IVR directly. If the call comes to the IVR, then IVR starts to process the call. Now we try to visualize the call processing. In this process, involved nodes are basically MSC, HLR, interconnect switch, third-party network, and obviously access network, and also user who initiates the call or user who receives the call. At first, look at the flow of on-net call. Call is coming to the MSC, then MSC is verifying the call with the help of HLR, and then it sends to the call to the B party. Now comes the question, what is B party? B party is whoever receives the call or to whom the call is initiated, and A party is who initiated the call. Now let's see the flow of off-net outgoing call. At first, call is initiated by the subscriber for off-net outgoing call. Then the call comes to the MSC and then it goes to the HLR for verification. After verification, call is going to the interconnect switch. Interconnect switch then sends the call to the specific operator. For off-net incoming call, it first comes to the interconnect switch, then it comes to the MSC. MSC sends it to the HLR for the verification, and after verification, call is delivered to the subscriber. Now in case of peer-to-application call, it can come from user or third party or any other network. Call will come to the serving MSC from the switch or user. Again, call can come to the interconnect switch from the third party or other network. For both cases, switch will forward the call to application. When call comes to the MSC from the user, then in some cases MSC sends it to the HLR for authorization and processes it, while some other cases call is routed to the application. Now we can see the SMS process. SMS is processed by SMSC. We can divide the work process of SMSC in 4 steps. Its first job is to receive the SMS from different node. Then it takes the decision to send the receive SMS to the accurate destination by analyzing the number of the SMS. And then this SMS is stored to the SMSC. In some cases, SMSC sends the SMS first, then it stores it, while some other cases vice versa happens. SMS is an asynchronous process. Sometimes it will not deliver the passage at once. First, it tries to deliver the SMS. If fails, then SMSC stores the SMS to itself. Later, it tries again to deliver the SMS. SMS can come to SMSC from different sources. It may come from its own subscriber network, or it may come from the other network through the interconnect switch. In the similar way, SMSC can receive SMS from the application. SMSC can also send SMS to the application. For the SMSC, we can receive SMS through application which comes from the interconnect SMS or external operator. For third-party SMS can come either from the interconnect switch or from the application. Now we see the SMS process in details from the network perspective. At first, we look into the MO-SMS from subscriber. That means if a subscriber wants to send a SMS, then this SMS is delivered to the SMSC from the subscriber. First it comes to the MSC, then it is sent to the HLR for verification, and then only it is delivered to the SMSC. If the SMS comes from the external network, then it comes through the interconnect switch. This SMS is delivered to the SMSC by the interconnect switch. Sometimes SMS comes from the third-party operator through the application. In this case, SMS comes to the application from the other operator, and then application submits this SMS to SMSC. Now we see how subscriber receives the SMS. SMSC receives the SMS from different sources. If SMSC finds that this SMS needs to be delivered to any subscriber, then SMSC sends this SMS to that subscriber serving MSC. Serving MSC finds its location and checks its status by HLR, and finally SMS is delivered to the final subscriber. In the same way, SMSC can send SMS to the external network through the interconnect switch. Again, it can be sent to the application through the external network. SMS comes to the application from the SMSC, and application sends it to the external network by the separate channel. Now let's see the USSD process. This is a session-based process. At first, the subscriber dials a number in a specific combination. Then this number is routed to the USSD gateway. After that, USSD gateway initiates a session. Once the session is initiated, information is exchanged to the subscriber through this session. USSD is relatively a secret channel and much more reliable. For example, SMS can be failed to deliver after it goes to the SMSC, and SMS can be failed in different points. But USSD is relatively more reliable. Either the session will be established or the session will not be established. If a session is established, then information exchanging is more reliable. There is no possibility that application sends an information but it's not delivered to the subscriber. So the information that is exchanged through the USSD is much more reliable, we can say. Now let's see how the USSD process with association of network components. User dials a USSD stream, for example *123#. Then it is authenticated from the HLR. USSD gateway receives the information whether the subscriber is active or not. USSD gateway starts interaction with any application on the base of dialed stream. Finally, a communication channel opens and it comes to the subscriber through the application, USSD gateway and switch. It's a single session. Further communication will take place through this established session. Now let's see how Internet Service or WAP works. For Internet or WAP service, there is an Internet Gateway, which is responsible for Internet access of the subscriber of an operator. Basically, Internet Gateway is a combination of different equipment of different operator, like CDMA operator and GSM operator. In CDMA network, it is a combination of PDSN and final Internet router. Again, in GSM network, it is a combination of SGSN and GGSN. Through this Internet Gateway, the subscriber can access the Internet. If a request comes to the switch, then it comes to the PDSN router or SDN router. For our understanding, we'll say that request comes to the Internet Gateway. Internet Gateway forwards this request to the AAA so that it can be found that this subscriber is allowed to use internet and the type of package that a subscriber will avail. His charging will be also known in this section. Then AAA authenticates and authorizes the subscriber request for the service. Then this authorized request goes to the Internet Gateway, and this Internet Gateway forwards the subscriber towards internet so that subscriber can use this internet service. WAP is another type of service which is similar to internet service. Through the WAP service, we can browse the WAP-based sites. If WAP request comes to the Internet Gateway, then it goes through the WAP gateway. When a request comes to the WAP gateway, then it interacts with the AAA and passes the subscriber to the internet through Internet Gateway. Generally, when a WAP request comes, then it pushes phone number and other information in its HTTP header, so that the application which is serving the WAP site can build the custom logic with the help of this information. Internet offers the wide range of services. That's why we can use all kind of services like Google, Yahoo and Facebook. So it offers more service providing opportunity than call or SMS. Now we'll see how we can see internet access in details. In this case, there's a constant communication between access network and Internet Gateway. Basically, this communication is established for 3G network or CDMA network. For the initial CDMA or first generation data access, this constant communication between radio access network and Internet Gateway was not available. We'll not go into details of this communication. Now we see the basic user flow. Request comes to the MSC from the user and verified from the HLR. If the request is WAP request, then it is passed to WAP gateway. And if it is the internet request, then it is passed to the Internet Gateway. For both the cases, request is forwarded to AAA. If AAA gives authorization, then request is forwarded to the internet. This is the basic concept how internet is accessed. Now, so far we have seen how the services are delivered, like how the voice call is processed, how the SMS is processed, how the data service is processed. But the question comes how the subscriber is charged for the services. Owner of the service is responsible for the charging to the subscriber for their services. Like for call, MSC or switch is responsible for charging. For SMS, SMSC is responsible for charging. For internet, Internet Gateway is responsible for charging. For WAP, WAP Gateway is responsible for charging. Generally, USSD doesn't charge. If the charging is applicable, then associated applications are responsible for charging. Internet Gateway doesn't charge the subscriber directly. For charging, it depends on AAA. AAA charges and gives authentication or authorization, then the request is processed. For charging, there are two types of scenarios. One is prepaid and another is postpaid. Prepaid means subscriber pays first, then he uses the service. In postpaid, user first uses the service and then CDR is generated. Then billing system pulls those CDRs and processes those and subscriber is charged. For charging the prepaid subscribers, there is a single node which is called IN or intelligent network. All prepaid subscribers are charged through the IN. That means switch or SMSC or AAA or WAP gateway or the applications for USSD gateway have to interact with the IN for prepaid subscriber charging. So for the prepaid billing components need to interact with IN, and for postpaid CDR is generated. Billing software pulls the CDRs and processes those for charging. Now consider that we are writing an application. How the subscriber will be charged for this application? For the prepaid subscriber, it needs to interact with the IN, and for postpaid, CDR will be generated. These CDRs will be pulled by the postpaid system and subscriber will be charged. Now we try to see the process flow and how does it work. When user requests a service, then it comes to the MSC, and MSC takes authorization from the HLR. Say for example, the request is a voice call, and if it is prepaid voice call, then it goes to the IN for the prepaid charging. If it is a postpaid call, then the CDR will be generated. Then this CDR will go to the postpaid billing system. If the request is a SMS, then it goes to the SMSC, and if it is a USSD request, then it will go to the USSD gateway. For internet service, it will go to the internet gateway, and for the WAP service, it will go to the WAP gateway. If the serving request comes to the SMSC, for prepaid charging, it will interact with IN, and for postpaid, it will generate the CDR. In the same way, request from WAP gateway and internet gateway goes to the AAA. AAA interact with the IN for the prepaid, and for postpaid, it will generate the CDR. For the application, every service owning node will interact with the application separately. If additional charge is needed, then for the postpaid CDR will be generated, and for prepaid, it will communicate with the IN. Finally, generated CDRs are pulled by the postpaid billing software, and it generates the bill. If any application gives any service, then it had to go through the delivery channel service like SMSC, USSD or data. It means first charging is done by either MSC or SMSC or USSD or WAP gateway or internet gateway. And if additional charging is needed, then application can do that. Application charging is two-step charging. Mainly charging is done in the service layer, and then application can charge. If we go into the details of service charging, then we know that upon which components we can charge a subscriber. First component is who is requesting the service or source. Then which service is requested, like voice, SMS or video. That means who is requesting the service, what is requested, for whom it is requested, whether it is an on-net or off-net service, or it is requested to application, and when it is requested, like it's morning, daytime or nighttime, or it's a special day like Victory Day or Eid Day. So timing is one possible pricing variable which we can use for charging. Another charging variable is usage volume. For example, for more use there is one kind of rate, and for less use there is another kind of rate. If we send 100 SMS, all SMS is free, or if we talk 100 minutes in a month, then subsequent on-net call is free. We can set price by using different kind of pricing variables. As a whole, basically there are four types of pricing variables. One is source, another is destination, and type of service, time when the service is requested, and the volume of user. Service channel doesn't contain more information than this. So if we want to charge, then we have to use these four type of pricing variables. All kind of packaging or play around is done on the basis of this four information. Prepaid system and postpaid system can charge by using these pricing variables. In some cases, postpaid systems has more flexibility because in postpaid systems CDR is generated, and postpaid system can use this information of CDR for the charging. For this billing software may need some additional changes, but logically it's possible. There are another two types of charging option in the charging system. One is subscription, which is the recurring charge. It means in every week there is a 5 taka subscription or monthly 10 taka subscription. Sometimes there is event-based subscription. It means to download a ringtone on a certain time, then 10 taka will be charged. For a specific event, there is a charging option in our charging system. Generally, service owning node can trigger charging system on the base of these four pricing variables. Both prepaid and postpaid systems includes in this charging system trigger. Every system has separate capability. When we do the service design, then we only consider the common feature set for charging. The postpaid has more capability than the IN. We do not charge for the extra capability. The reason behind that, we have to have that kind of pricing plan that is applicable for all serving system and for all subscriber. So there is a common set who supports both the prepaid and postpaid serving system. We go to the market with this kind of pricing plan. So far we have seen general services like basic SMS, basic USD service, basic call or video service, and basic data service. Beyond these services, we have the opportunity to deliver other kind of services like update of SMS, news update through SMS, news update through call, hearing song by using call, CRBT, hearing song when we call other person. In our telecommunication network, there is opportunity for different kind of applications of this type. This kind of non-telecom service which we deliver over telecom network is called value-added service, in short VAS. Now we see how these value-added services are positioned in the network. Every network has different serving nodes and different types of service delivery channel. Basically, application integrates with service delivery nodes. For example, IVR integrates with MSC, SMS application interfaces with SMSC, USSD application interface with USSD gateway. Internet applications can reside on any internet server which will interact with the subscriber using TCP/IP. We have to charge the subscriber for this kind of service or applications. This charging is also done through the charging system. What we can do, application will not charge. That means subscriber will be charged per SMS, per call or per minute through MSC or SMSC or per volume of data transfer through the internet gateway. Otherwise, application can charge specific subscriber. Like for latest ringtone, subscriber will be charged more, or some ringtone may be completely free. We can do this kind of different charges through the application. If an application wants to charge separately, then it needs to be interfaced with IN or postpaid billing system. If application wants to charge, then subscribers are charged from two places. One is from network node and another is from application. If we want, we can close the charge of network node. If we stop charging from the network node, then it is called zero charging. In that case, application will charge the full amount from the application itself. There may be another situation where application will not charge. Here one concept is very important, that is zero charging and no charging. Application will not charge means application doesn't need any charging interface with IN or postpaid billing system. No charging means no request is coming to the charging nodes from the application itself or network node itself. Zero charging means there is a charging request or there exists a charging interface, but we are not doing any charge or doing zero charge. So we see that no charging and zero charging is not similar. One is we have capability to charge, though we can charge or not. But there is a charging interface open which we can utilize according to the business logic. No charging means there is no option for charging. From application, no charging means there is no charging interface. Whole charging can be handled through the network node. Again, we can charge according to our need. If we have the charging interface but we don't want to charge, then we will go through the zero charging. It's like we have channels but we are not utilizing it. Or we will send charging request which will be zero charging requests, so that subscriber will not be charged. In the similar fashion, if we want to stop charging in MSC or SMSC, then we have to configure the charging to VAS 0. Either MSC will do the zero charge or SMSC will do the zero charge. In this way, the combination of application and network node, we can charge a service. Now let's discuss about location-based services. Location-based service is completely application-based service. In operator's network, it is known as PDE or CDMA network and GMLC for the GSM network. If this node is present, then we can say the subscriber's position precisely. If this precise location is obtained from the GMLC, then we get different information and we can develop different application by using this information. Location server is an independent server with which different application interrupts and fetch the information of the location, and service is delivered according to the location information. From three places we can know the operator's network location. One is HLR or registration server. From the HLR we know the position of BTS or the point of access network. Other is location server, which is optional item for network. And then the last one is base station of access network or BTS. Some BTS have some kind of facilities. We can broadcast some information from the BTS. Mobile device can listen this information through its specific channel. We can see the location in mobile devices with the help of this information. We can also avail one or two promotions like dial here to save certain % on call cost. We can promote this kind of small strings. As a whole, our application can tell exact location of the user by interfacing with the information of the location elements. And different kind of service or content can be delivered according to the location. Location server is an independent element which is GMLC in GSM network and PDE in CDMA network. This can tell the subscriber location very precisely, almost within the radius of 5 meters. On this basis, we can deliver different services to the subscriber. Now let's try to wrap up. At first, we have seen the telecom network components from a very high level. Then we have seen how the services are delivered. We have seen 4 services: call, SMS, USSD and WAP or internet. We have also seen how the charging is handled. Then we saw how VAS or application is positioned in the network. We have also seen that how location-based service is positioned. As a whole, I tried to give a high-level view of the telecommunication network. I believe after seeing this presentation, you would be able to understand how telecommunication network works. That's all. Thank you.